Assalamu alaikum, guys. This is Engineer Zishan Akbar from Civil Engineering Excellence Academy. This is my second lecture about civil engineering basics. In this lecture, I will discuss some basic concepts about hydraulics engineering. So, before going to start my lecture, I would like to request all of you to kindly subscribe my channel and press the bell icon so that you can get notifications for all my videos. Thank you very much. Let's proceed with the lecture. This lecture starts with the definition or basic concept of discharge. So all of us wants to know that what is the discharge? So the answer to this question is very simple, that the discharge is the volume. Discharge is the basically volume. That volume may be in meter cube, maybe in feet cube, maybe in liters, maybe in gallons. This is the volume of water or any fluid or any liquid flowing through any point that we are interested in a single point at for a single point values. Suppose this is our channel and we are standing at some point here. So we only can observe values at this point. So flow is coming from this direction. So we can say this as upstream direction and this is downstream direction. Flow is going towards this side. When we are standing at this point, we will observe or we will note or we will gauge the number of liters or meter cube or feet cubes or liters or gallons of water or any liquid flowing through this point in unit time. Suppose that uh, we are measuring 400 meter cubes of water passing this point for this channel, and the time for observation was 30 seconds. Let's suppose. Then the discharge will be observed volume divided by the time. So simple, if we divide the volume of flow or volume of water with the time of observation, then we will get discharge. This zero is cancelled with this zero, and when we will divide this 40 by 3, it will be 16.67 meter cube per second. So this is our discharge unit. So this is value of discharge 16.67 at this point of channel with a volume flowing of 400 meter cube in 30-second time. So this is the basic idea for calculating discharge. So discharge is also known as flow through any channel. This is mostly nominated as Q. So again, we can read the definition. This is the volume per unit time, but one condition is given that you have to select any point in the channel. So any reference point. In our case, this point is, suppose this is a location, so then this location is known as our experimentation or our gauging point. So the units of discharge then will be, as we calculated in the example, that this will be meter cube per second. This is also called cumex. This may be in fit cube. If our volume is in fit cube, then this will be fit per unit time. Time means second. Fit cube per second, it is known as Q6. This may be liters per second or gallons per second. There may be different units in different literatures, so you need not to worry about these units. So you must know the basic definition. The definition is volume divided by time at any specific point. So the formula for discharge is very simple. From equation of continuity, we can calculate. In most of questions, we can simply calculate the discharge by this formula. This is known as equation of continuity. In this equation, Q is the flow discharge This may have any units from these. This may be the discharge unit of flow. This may be or this or this. So mostly meter cube per second mean cumex and fit cube per second are used in different books. The area is flow area. This area may be in meter square, fit square, or millimeter square, inch square, and v is the velocity of flow or flow velocity, that may be in meter per second or fit per second or any other unit, that is length divided by time. So there are different flow types. So this second slide will tell us different names or different types of flows. These flow types are major types. They do not include the minor types or other types. I will include those types in my next video in Civil Engineering Basics Part 3. So here we are going to discuss major types of flow. The first type of flow is uniform flow. The second is non-uniform. Third one is steady. Fourth one is unsteady. Most of the students intermix these things, these steady and unsteady, and uniform and non-uniform. So you have to keep in your mind the basic ideas or basic differentiation between uniform and non-uniform flows, steady and unsteady flows. So I will give you an idea to remember that how can we differentiate easily, or how can we remember easily the differentiations. That is a single point or single letter by using which you can differentiate these four types. Fifth type of flow is laminar flow. Sixth type is transitional flow. Seventh is turbulent flow. Eighth one is subcritical flow. Next is supercritical. And the last and 10th number in this video presentation is critical flow. So we will start with uniform flow, this one, and we will complete all these 10 types of flow in this today's lecture. So what is the uniform flow? Uniformity. We have heard about the uniformity. Uniformity means we have to be arranged in a pattern. We have to be arranged in a pattern. It means that if this is a channel bed and there is some flow in the channel like this, we have divided this channel into two parts. Oh, sorry, we have marked two stations. That is one station observation point, and this is two station or two observation point. At this station, one person is taking readings at the single time, and at this station, the other person is taking the readings. At suppose a person is standing at one location at 10 a.m. and the other person is standing at this second location same at the same time 10 a.m. The depth of flow at this section, uh, when there was a time of 10 a.m., he observed the depth at this point as y1 as 1 inch. Suppose the other person standing at this point observed the depth y2 at this second point to be 1 inch. Then what does it mean? The distance between these points may be any distance. There may be any distance. Suppose this is 100 meters or 100 feet. So there are 2 points located at some distance. In this example, 100 feet away from each other. So two persons are standing at these two different locations. First person observed at any specific time the 1 inch flow depth, and the second person also observes at the same specific time at second location the depth of flow is 1 inch. What does this mean? It means that the depth of flow is constant. The depth is flow is not changing with respect to this distance of 100 feet. This may be 1000 feet, this may be 1500 feet, this may be 10,000 feet, but in this case along the 100 feet location, when these 2 points are 100 feet away from each other, the depths of flow are same. Then this means that the flow is uniform. It has kept itself uniform from point 1 to point 2. So simply we can define that a flow is uniform when its depth is equal to some constant value, some k value. Under what condition? Under distance condition. It means that if we are noting the values of flow depth at different distances in a single channel, then the depth is equal to a constant value. It means constant means same values. Here it is 1 inch and here it is also 1 inch. So the depth is constant at different distances. Then the flow is known as uniform flow. So what is the definition or basic definition or correct definition for this uniform flow? This is same as I elaborated in the figure. When depth and velocity, these both are basic parameters of flow. First one is depth and second is velocity. When depth and velocity of any flow remain constant or unchanged at various locations of a channel. Various locations mean with respect to distance. At 100 feet from one to other point, at 1000 feet or any other distance, then the flow is known as uniform flow. A flow is always called uniform when the depth and velocity of flow are constant at different points in a single channel. Or other definition may be a flow in which there is no change in velocity and depth of flow with respect to space or with respect to distance. This is the condition for a flow to be uniform. So if we want to see it by a pictorial view, we can draw a simple line, this line. What the thus what does this line depicts? This line is originally depicting the channel bed. This is the bed of the channel in which water is flowing. This dashed line is showing the surface of water or water surface in this channel. This dashed vertical line shows the section 1, which is our section of interest, or our first person of for experimentation is standing at this point. The depth at this point is known as y1, this one. Another vertical line is drawn at some distance d from this section 1. This is known as section 2. The depth of water at this section 1. Then what is the condition for uniform flow? This is written in green here. At both sections denoted by red lines, depths are depths of flow are observed to be equal. If this depth of flow y1 is equal to this depth of flow y2, then the flow will be uniform flow. Okay, now we will move towards the non-uniform flow. Then what is the non-uniform flow? Simple, we can take inverse as the definition for non-uniform flow. Means when depth and velocity of flow of any for any channel, when the depth and velocity of any flow keeps on changing at various locations of a channel with respect to distance, the depth and velocity are not kept constant, are not constant in a flow, then the flow will be known as non-uniform flow. So simply the other definition may be a flow in which there are fluctuations in velocity and depth of flow with respect to space or distance. In uniform flow, in simply uniform flow, there were no fluctuations observed. But if you observe any fluctuations, any changes in velocity and depth at various distances in a channel, then the flow will be known as non-uniform flow. Then this may also be depicted by a figure. Suppose this line is representing the channel bed. This is channel bed. This is the water surface. Suppose we have a vertical section here as section 1. The depth of water at this section is y1. Suppose I can say this as 1 meter. The depth y1 is 1 meter. Other vertical line is representing section 2, and depth of flow here observed is suppose 0.8 meters. So we can say here that y1 is not equal to y2. It means that at a distance d between these 2 points, at a distance d, this may be 1 kilometer distance. In a distance of 1 kilometer from section 1 to section 2, the depth of flow was changed from 1 meter to zero point 0.8 meters. It means that there was a fluctuation, there was a change in depth. If depth is changing, then there will be change in velocity, but we only observe one parameter. You may observe depth, you may observe velocity. If any one of these is changing with respect to distance in a channel, with respect to distance in any flowing channel, then you will say that this flow is known as non-uniform flow. Simply, so by observing this condition in this figure, you can simply write at both sections denoted by red lines, there is a change in depths, or you can say that depths of flow are not observed to be equal. Y1 is not y equal to y2, so the flow is simply non-uniform. The next case is steady flow. Here is the point which I am going to uh, tell you as a clue. This point is T. In steady, you can see T here. T. T stands for simple time. T stands for time. In steady flow, there is a T which means time. We can simply uh, click it for to remember the definition. It means a flow is steady when depth and velocity are constant with respect to time. Then the flow is known as steady flow. So simple. If steady is for time, then means uniform and non-uniform flows will be with respect to distance. So this is the point which can make you able to remember the definitions or differences between steady and uniform flow, unsteady and non-uniform flow. So simply, uniform flow is about uniform and non-uniform are classified on the basis of distance in the single channel at two different locations, but this steady flow is observing the parameters of flow with respect to time at a single location. In case of uniform flow, we had drawn two different points. But in case of this steady location, we will not draw this like this one. We will draw another channel. Suppose this is a channel. We will set only one section. Suppose this is one section as a observation section. Suppose a person is standing here to note the values, and he observed that y1 is equal to 1 meter at 10 a.m. and he went to work or for some other activity, and he came back at 12 p.m. And then at the same location he observed the depth of water at second time y2 to be 1 meter, same like at 10 a.m. These both depths are same with respect to time at a single point. We are not changing the distance. I told you from this t, we are just changing the time. Time is changed for 2 hours, that is 10 a.m. to 12 p.m. In these 2 hours, there is no fluctuation or change in depth of flow, so the flow is known to be steady. So, how can you define the steady flow? The flow is said to be steady if there is no change in flow parameters for with respect to time at a single point. Our observation point is constant, fixed, but our time is flexible. In case of uniform and non-uniform flow, our time was fixed, but our station or gauging station were not constant. So this difference should be kept in mind. If we study the basic definition for steady flow, when the depth and flow, here depth and velocity are basically representing flow parameters. Flow parameters may be depth of channel, may be elevation of channel. So if any one of the parameters is changing with respect to time at a single point, then the flow will not be steady flow. Flow will be unsteady. So how can we define steady flow? When the, you can say in place of depth and velocity, when the parameters of any flow remain constant or unchanged at a single point with respect to time. This time is from t of steady. When the depth and velocity of flow remains constant or unchanged at a point with respect to time in a channel, then the flow is known to be steady flow. A flow in which there is no change in velocity or depth of flow with respect to time, then the flow is called steady flow. This is the same definition which I told you in the first two rows. So, how can we draw or can understand from figures? Suppose we have divided a channel. Suppose when we are taking channel, this is known as bed of the channel. This is channel bed. This is water surface. Dashed line is showing the water surface. This is section 1 at time is equal to 0 second. Suppose we are standing at a point in a river or in any channel, across any channel, then this point we are standing at suppose 10 a.m. So the time with respect to our observation will be 0 second at 10 a.m. So we are starting observation at 10 a.m. So the time for experimentation is 0 second. At this section, at time is 0 second in 10 a.m. in the morning, the y1 depth was calculated to be 1 meter. Same. After some time at section 1, after say 30 minutes at 10:30, you came again at the section 1 10:30 a.m. And what did you observe? You observed the depth of flow as y1 dash. This was observed to be 1 meter. So you can say that with respect to changing time, there is no change in the depth of flow, so the flow is steady. There is no difference. This is the same section, but at different time frames. This is at 10:30, t is 0 second, 10 a.m. when time was 0. This is at 10:30 a.m. when the time of experimentation was 30 minutes. So at both the times at a single point, section 1, this is also section 1, this is also section 1. This section is for 10 a.m. and this section is drawn for 10:30 a.m. So there is no change in depth of flow, so this is will be steady flow. What will be unsteady flow? Simply the unsteady flow will be when the depth and flow velocity keep on changing at a point. At a point mean the point of observation is fixed in a channel with respect to time, then the flow is known as steady. So how can you show this steady flow? This line is showing the channel bed. This is water surface. This is section 1 at time 0 second, and depth of flow here was observed to be 1 meter. And after 30 minutes, suppose 10:30 a.m., we observed that y1 dash to be 0.5 meter. So what does it mean? It means that depth of flow has decreased. Decreasing the depth mean depth has changed from 1 meter to 0.5 meter. So this is unsteady flow because with respect to time at 0 second and at 30 minutes, the depth of flow was not consistent. It was not similar to the previous depth when as it was on T1 at 0 seconds. So we can say this flow is unsteady flow. So uniform, non-uniform, steady and unsteady flows are only observed by going to any specified station or any specified channel. You cannot observe by sitting in any class or lab or etc. So the next type of flow is laminar flow. What is laminar flow or streamline flow? When a fluid moves, its particles follow some paths. Suppose the particles are moving. and they follow these paths. These paths are known as streamlines. Streamlines. So streamline flow or laminar flow means that there are regular movement of flow. There is a regular movement of flow, that disturbance in the flow is approximately equal to zero, or there is no disturbance for the flow. In any channel, there may be a closed conduit, there may be a pipe flow, pressurized flow, or there may be a open channel flow. So if there is no disturbance in the flow, that flow is likely to be laminar or streamline flow. So simply we can define that if a flow is flowing in a regular manner, there is no disturbance in the flow in any channel, then that flow may be a laminar flow. So the basic definition for this flow is when all the particles of a liquid follow regular paths for their movements and their paths do not cross each other. What does the crossing means? Crossing means that if a particle is moving on this path, then the other particle coming from other side or coming from the same side will not cross this, the path for the previous particle. So this is not in the case of laminar flow. In laminar flow, there will be straight paths or there will maybe curved path, but these streamlines will never cross each other. So from this figure, we can easily understand that streamlines are straight. They are not disturbing the path of each other. So these lines, these streamlines, are these flow lines are representing laminar flow. A flow is observed because laminar flow cannot be observed by the naked eye, or we cannot observe easily any flow type in lab or in any channel like like uniform, non-uniform, steady and unsteady flow. So we will have to calculate some data of the fluid which is flowing in the channel and some characteristics of the channel, and we will get out some reference value. This reference value in case of laminar flow is Reynolds numbers. Reynolds number. If the Reynolds number for any flow and any channel is less than 2000 approximately, then the flow will be streamline or laminar flow. So what is the Reynolds number? Reynolds number is simply the ratio of, it is simply the ratio of inertial forces to kinematic viscosity or dynamic viscosity. Those are known as frictional forces, sorry, inertial forces to frictional forces. Reynolds number is the ratio of frictional to inertial to frictional forces. So simply from this figure you can see that vertical axis is representing the Reynolds number. So flow is starting at t is equal to 0 second, and at some time from starting, the flow's Reynolds number was observed to be 2000. You will mark this 2000 on your graph and will draw a horizontal line. Where the horizontal line meets the flow line, then this range from this point to this point, you can see this red hole as laminar region. So flow will be laminar from this point to this point. As the flow is decided, the laminar, turbulent, or transitional flow are decided with the help of Reynolds number. So we must know the formula for Reynolds number. Reynolds number, keep in mind that Reynolds number is applied to both flows. That may be pipe flow, that may be open channel flow. This should be kept in mind. But formulas are different for both the types of flow. For pipes, the Reynolds number is somewhat like this. Here, rho is the density of fluid, V is the velocity of flow, D is the diameter of the pipe, and mu is the dynamic viscosity. This is dynamic viscosity, this is kinematic viscosity. Both of these are related with density. So we simply can say that kinematic viscosity nu is equal to dynamic viscosity divided by density of fluid. So for pipes, there are two formulas, one involving density and dynamic viscosity, and other involving only kinematic viscosity. So for open channel flows, there is some difference in the formula that you will convert change this d by the hydraulic radius of the channel. This will be equal to 4rh. D is replaced by 4rh. This rh is the hydraulic radius. This hydraulic radius in open channel is calculated as area of flow to the wetted perimeter of flow. We will discuss these things inshallah in next video. So for open channel flows, for dynamic viscosity formula is this one, and for kinematic viscosity formula for Reynolds number is this one. So moving towards the transitional flow, what is the transitional flow? Transition means in between. What does it in between means? We have two types of flow, that is laminar and turbulent. If a flow exists between a range for laminar and a range below the turbulent flow, then that flow will be characterized as transitional flow. The flow type starts with the end of laminar flow to creation of complete turbulency. I will describe this definition in from figure. In this flow type, flow is neither completely laminar nor completely turbulent. So in this figure, you can see from this line to this line, Reynolds number is varying from 2000 to 4000. It means that when Reynolds number's value is from 2000 to 4000, the flow is not laminar, neither it is turbulent nor it is laminar. Then what the flow type will be? This will be transitional flow. Why? Because when Reynolds numbers increases from 2000, there are turbulent bursts in the flow. So it will not be a completely laminar, but at some places the flow will have streamlines as well. So at some points there is turbulency, at some points there is a laminar characteristics. So we say that this flow is the mixture of both. There is some part of flow which is laminar, and there is some part of flow which is turbulent. So this area is showing the flow which is turbulent. This flow is observed when Reynolds numbers value is between 2000 and 4000. So the next type and seven types of flow is turbulent flow, when all the particles of liquid do not follow regular paths for their movement and their paths cross each other. In case of laminar flow, paths of particles were not crossing each other, but in case of turbulent flow, paths will cross each other. So this flow is some type of irregular flow. So the turbulent flow is also named as irregular flow. This is turbulent or irregular flow. For this flow, Reynolds number is greater than 4000. If from your calculation formula, from formula, you get Reynolds numbers to be greater than 4000, then you can classify this flow as turbulent flow. So you can see here in this figure that all lines are crossing each other. You can see here that these both lines are crossing here. Here is the crossing of lines. Here is the crossing of lines. These lines are crossing each other. So when streamlines are crossing each other, then it means that the flow is not streamline flow. It is turbulent or irregular flow. In this left figure, you can see this is 4000 Reynolds number, and increasing Reynolds number will increase the turbulency of the flow. At this point, flow is weakly turbulent, and as you increase the Reynolds number, the turbulency will be very high, or very strong turbulent flow will be observed. At this point, laminar flow is very weak, has become very weak. At this point, laminar flow was very strong laminar flow. So below this, laminarity increase, and above this, turbulency increase. And between these 2 points, transitional flow is observed. So if you can see from this elliptical hole that this area is showing the turbulent flow type, for which Reynolds number is 4000 or greater than this value. So next one is subcritical flow. Then how can you distinguish subcritical flow from supercritical and critical flow? This is an other criteria for flow classification. A flow in which velocity head is comparatively less as compared to depth of flow, this is called subcritical flow. A flow in which velocity head, what is the velocity head? Velocity head is v square divided by 2g. For any open channel flow, velocity head is v square over 2g. 2g. This is comparatively less. This v square over 2g is comparatively less as compared to depth of flow. This is called subcritical flow. If we can see a figure, here you can see this hole or this value. You can see these two arrows, and you can see here the value as v1 square over 2g. This is velocity head. This you can see here that from this point towards this point we have subcritical flow. So this flow type is subcritical flow. Here the velocity head is v1 square over 2g, and this has just this value, this one. So its value is very small as compared to y1. You can see here that y1 is very large as compared to v1 square over 2g. So we can say that velocity head is comparatively less. v1 is very greater as compared to v1 square over 2g. y1 is very has very higher value. So we can define the subcritical flow that this is a flow in which velocity head is comparatively less as compared to depth. Then this flow will be subcritical flow. This is the basic definition. Describing this or defining this by Froude number is not a good one. That is the indication, that is the numerical indication, that is not theoretical indication. This is the theoretical indication from specific energy diagram that any flow in which velocity head is comparatively lower than the depth of flow, then the flow will be known as subcritical flow. From numerical indication, you can say that when a Froude number is observed to be less than 1 for any flow, then the flow will be called as subcritical flow. As this flow is decided with the help of Froude number, so Froude number is equal to v over square root of gy. This is known as velocity of flow. Velocity of flow, and this gy square root is known as celerity of fluid waves, celerity of water waves. This is known as celerity or depth dependent acceleration. This is known as celerity or depth dependent acceleration. So this Froude number, keep in mind that Froude number is only applicable to open channel flows. This is not for pipe flows. Reynolds number is for both open channel and pipe flow, but Froude number is applicable to open channels only. So this is important point to keep in mind here. So what is V here? V is the velocity of flow. G is the gravitational acceleration. Its value is randomly used at 10 meter per second square. And Y is the depth of water for open channel flows. Why Froude number is related to open channel flow? The first factor is G, because gravity is involved. G is involved. It means that only the flow which is flowing under the gravity will be considered for Froude number, for calculation of Froude number. So in open channel flows, gravity is causing the water or any fluid to move. So we will calculate or we will apply the Froude number criteria. If pipe is flowing full, then Froude number cannot be applied. But if pipe is flowing partially full, then the Froude number can be applied because in that case flow will be under gravitational forces. Next type of flow is supercritical flow. What is supercritical flow? Simply, here we observe that velocity head is comparatively less. So in that case, in case of supercritical flow, velocity head is comparatively more with respect to or as compared to depth of flow, then the flow is known as supercritical flow. In this case, the Froude number is greater than 1. If we can see from figure that this is the velocity head for supercritical flow. V2 square over 2g. This is velocity head for supercritical, and supercritical is this flow type. So for this, V2 square over 2g is somewhat more as compared to Y2. You can see Y2 has a less value. Uh, I have drawn these boxes to show you that which value is greater and which value is smaller. You can see this box to be large, so this will give a large value of V2 square over 2g, and depth of flow will be minimum or less as compared to velocity head. So, a flow in which velocity head is comparatively more as compared to depth of flow, then this flow is known as supercritical flow. So, last one for this video lecture is critical flow. This type of flow is the in which velocity head and depth of flow have somewhat intermediate values as of subcritical and supercritical. Means velocity head and depth have some intermediate values. You can see from figure this yc and this vc square over 2, this is vc square over 2g. See here, this is value of v1 square over 2g. For subcritical flow, value of velocity head is less as compared to critical velocity head. You can see here, and see here, this is the velocity head for supercritical flow. For supercritical flow, velocity head for supercritical flow is greater than critical flow, but for subcritical flow, velocity head is lesser as compared to critical flow velocity head. So, in case of depth, the subcritical flow depth is greater than critical flow's depth, and supercritical flow's depth is less than critical flow's depth. So simply we can see that yc is less than which value, that is less than y1. We can say that yc is less than y1, but y2 is less than yc. You can write a condition for critical flow here that yc is less than y1. You can see here the value of y1 is greater as compared to yc, and value of y2 is less as compared to yc. What does this mean? It means that yc is in between y1 and y2. So here I wrote as depth of flow have somewhat intermediate value as of subcritical and supercritical flow. So depth of yc is in between y1 and y2. These y1 and y2 are known as alternate depths. Sorry, this is alternate, NAT, alternate depths. So this is for velocity, oh sorry, depth. Now for velocity head, we will see the values from this figure. We'll use this figure. So I will erase and we'll start new. You can see here, this is v2 square over 2g, and its value is this one. We will write as v2 square over 2g. Now put here less and put here less. V2 square over 2g is, sorry, this is v square, vc square, this one, vc square over 2g. This value is less than what value? You can see here, this is only this length, and here you can see this box v2 square over 2g is greater than vc square over 2g. So means that vc square over 2g is less than y2 square over 2g. What does it mean? It means that velocity head for critical flow is less than the velocity head for supercritical flow. Now You can see here this value as v1 square over 2g. This is velocity head for subcritical flow. So this has less value as compared to critical value. So we'll write it as y1 square over 2g. So again, the velocity head value is in between subcritical and supercritical velocity heads. So we can simply say that the critical flow is that flow which has length, or sorry, depth of flow between critical and supercritical, and velocity head between critical and supercritical flows. For this flow, the Froude number is observed to be equal to 1. This is the flow which has least specific energy, means if you observe this point, the energy is minimum for this point, because this curvature is coming from here, touches this point and goes here. It means that this is the point where the flow has minimum E. This x-axis is showing E. So this is the point where the energy of flow is maximum. Beyond these points, energy is maximum. So this is the point where the energy of flow is minimum. So at critical flow, the energy of flow is minimum. Depth of flow is known as critical depth. The formula for critical depth is q square over g index 3. What does it? What is this q? G is gravitational acceleration. This small q is equal to discharge per unit width of channel. Unit width mean bottom width of the channel. So you can get this discharge intensity. And energy is called the critical energy. At this point, the minimum energy is known as the least energy, or least specific energy is known as critical energy, ECR. And formula for ECR is 1.5 times YCR. When you get YCR from this formula, you will multiply by this YCR by 1.5, and you will get the value of ECR. Thank you very much. If you have any questions from this lecture, from this video, you can openly ask me. Thank you very much for watching my videos. Recommend my channel to you, your fellows, or to other professionals if you like my videos. Take care. Allah Hafiz.